All right, so finally, we've seen conditional branching a little bit in several examples we've done so far, but today we're going to be talking about like the ways to say, hey, based on some condition, we'll execute some code, and then otherwise we might execute some different code or not execute any code at all based on that condition. And so we're talking about making decisions in VBA. So let's go ahead and download this books.xlsm, and we'll see the data that we're going to work with today. And so this data that we have here is just, I don't know, some data that I swiped off of some website. So I think these are real book titles. I don't even remember what the context was. So here's the ISBN, and then here's a little block of text that showed the title as well as the author of the book. And so our goal today is to be able to split this out. Now, of course, we could do this with, could we do this with like text to columns? We probably could do this with text to columns without too much trouble. But this is just some data that we're going to work with to kind of get introduced to the if function and the select case structure, and how can we make decisions based on our code. So let's go ahead and look at our code here. It looks like we don't have any module built into this one. So let's start off by inserting a module. And ultimately, I'm going to want to run through all of these. So let's just kind of quickly put in some code that will iterate across all the rows that we have here. So why don't I make a sub procedure called process data. And let's dim R as a long integer. Set R equal to, let's see, looks like we don't have any header on this data. So let's just start R off at 1. And then we'll do till. And is this worksheet name? This is just sheet 1 or sheet 6. Let's just assume we're working on the active sheet, so I won't specify the sheet at all. So cells, row number R, column number 1 dot value is equal to a 0-length string. Next. Anytime we've got a do loop, not next, but loop. Anytime we have a do loop, better put a do events in there. And then let's give us some way to get out of this thing. So we'll increment R. R equals R plus 1. And then let's print R as well as the ISBN, which is in column 1. Ooh. So if I run that, it should give me an error. Value. Debug.print VALUE. And so it does that. So it goes through my data and prints off the ISBN. That's delightful. Hopefully you're comfortable with a loop like this by now. Just show me how comfortable you are with what we have on the screen so far today. 5, 5, 5, 5, 5, 5. Wonderful. Good. All right. And so what I would like to do is I would like to begin by saying, here we've got this ISBN number here, and there's like different portions of this ISBN. So the first part of this ISBN actually says this is the book. So when the ISBN standard was made in the early 1970s, it was only for books, and they were 10 digits long. But then when we got like numbers for identifying other kinds of products, they said, well, great, we should make the ISBN kind of the same as all the rest of these products that we identify. And so today ISBNs are 13 digits long, and the first 3 digits just say it's a book. And then the rest of this actually identifies what the book is. And this thing on the very end is called the check digit. We'll talk about that later. So it's like, for folks that like know ISBNs, this 28 tells you something about the publisher, 79 tells you something about where it was published. There's like meaning to different parts. I don't know what they are, but there's like meaning to the different segments here. But for my use, I just want this as a single numeric value. And so I'm going to start off by saying, let's execute some code that will take in this ISBN, and it will ignore everything that is not a number. If it's a number, great, we're going to use it. If it's not a number, just forget it. So we're going to make another sub procedure here. In fact, it's kind of another little preview here. We're going to pretty soon, in fact, how soon? Pretty soon, as in next Monday, we're going to deal specifically with what we're getting introduced to today, but that is, so far, the sub procedures, the procedures that we've written have been sub procedures. It's a block of code to go and do something. We're now going to make another kind of procedure that's not a sub procedure. It's called a function procedure. Function procedure is exactly like a sub procedure. They're both procedures, but a function procedure, after it goes and does whatever it does, it's going to send a value back to where it was called from. And so instead of using the keyword sub to start, I'm going to put a keyword here of function. And then I'll give it a name. I'll call it numbers only. And just like with a sub procedure, I can give it a value to operate on. I will give this a value to operate on as well. I'll just call this data as a string. So remember, this little parameter that I'm declaring here really is just a definition of a variable that goes inside of these parentheses. So now what we're saying is, listen, when I call the numbers only function procedure, it's expecting to have some data sent to it. I got to send something to take in as the value for this variable. And the idea is that I will do something with that and then send the value back when I'm done. And the way that we tell it to send a value back is by saying the name of the function, numbers only, equals something. And right now, this function always sends back 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a very useless function. It would just always return the same value. We're going to get more sophisticated with it. Oh, and one more thing is that we can define, not only do we define the data type for the parameters coming in, but we can define the data type that this function returns as well. And so I do that just like after the closing parentheses, I give this a data type, numbers only. And I think I'm still going to want to return this as a string. So what I want to do is I want to say, give me your string with all kinds of other stuff in it besides numbers, and I will give you a string back that has just numbers. If you really want to convert that into a number, there's like built-in functions to convert strings into numbers inside of VBA, like cint will convert to an integer, cint. I give it something that looks like, it's a string that looks like a number, and then that will return like the numeric version of it. By the way, you can ask the type of any expression by this function called type of. It might be handy occasionally, type of. And then like type of, oh, it's not type of, sorry, wrong language. It's type name. So if I ask for the type of this as just a string, it'll tell me, hey, that's a string. I can convert that into a number, cint, like a built-in function to convert something to an integer. There's also clng, which converts it to a long integer. There's a cdbl, which converts it to a double precision floating point number. So like converting from strings into actual numeric values, there's a bunch of built-in functions for that. So we're just going to say, give me your string that's got letters and possibly something else in it, and we'll send back the value that is just the numbers. So even though this is returning a number, because the data type is a string, it will convert it to a string, but since it's returning a string, I'll put that in quotes. I should be able now to execute this just from like anywhere that I can put a single value. So here in my immediate window, print off numbers only. I got to pass it something, even though I'm not doing anything with what I'm passing it. Hello there. Hello there. And what will this return if I hit enter? What will it print? Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's just because that's what I told it to. It like doesn't even pay attention to what gets sent in. We're going to change that here in just a minute. The other thing that I want to point out here that's kind of handy is that when you create a function like this, you can call it from inside your worksheet as well. Let's suppose I had another sheet here and just said, oh, I want to do numbers only. And I'll give it some string to operate on. And it will bring back 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is actually how you create, you have some function that Excel doesn't do that you'd like it to do. You can like create the logic in VBA and then just use it from inside of Excel, inside of a cell. So that's not where we're headed today, but I just wanted to kind of lay that groundwork. We're going to spend some more time dealing with these here in just a little bit. I mean, like a couple of days. But here's what I'd like to do now. I want to now write this code so that when I send down here an ISBN, it will return back just the digits of the ISBN, not like without these spaces. And sometimes ISBNs have spaces in them. Sometimes they have periods in them. And so I would like to just give me the numeric version of that. And that's going to still just bringing back that one particular thing. But now let me do this. Let me just return data. Okay, so now when I run this, what's it going to print? What's the first character this will print? When I hit enter here, what will be the first character that gets printed out right here? It's a 9. Yeah, it's just going to return back the very value that we sent to it because we sent this value into this parameter. This variable now takes on that value, and we said just return them. We want to do some work on it in the meantime, but that at least shows us how do we get the value brought in here. So now, oh boy, I'd like to make this thing kind of look at this character by character, and then depending on some characteristic of that character, decide whether it's going to be accumulated into what I'm going to send back or not. So let's start off with a loop here. I have to use a for loop for this one. I'm going to need a control variable for dim x as an integer. So I'm assuming that the data that gets sent in is not going to be more than 32,000 characters long. Probably a pretty good assumption since I'm planning to deal with ISBNs here. And then let's just make a for loop. For x equals 1, 2, and I want this loop to go for as many characters as there are in data. So as it turns out, there's a function called len that will tell me how long something is. It's short for length. And that tells me that string that I gave it has 17 characters in it. So if I send x from 1 to the length of the data that got passed in, then that loop will iterate once for every character that's in that loop. And in fact, let's do this. Let me dim 1 char as a string. Who can remember how many bytes of overhead there are in every string? Like the first little part of memory that we use for that, all it says is it says how long the string is. It's actually 4. So 4 bytes just to use to tell me the length. But as it turns out, I didn't really show this to you when we're talking about variables because it's not that big of a deal. But I can make a string fixed to a certain number of characters. And I do that just by putting a star here and the number of characters I want. This would work totally fine just using string without putting the star 1. I know I'm only putting 1 character into this string ever. It's called 1 char, 1 character. And so this allows me to bypass the overhead to say how long it is, because the only thing I can put in is just a single character. Yes? So yeah, you can put in another, I could say, 10 characters. This string will be exactly 10 characters long. What would happen if I put in less than 10 characters? What's that? Well, I'm putting in less. I'm putting in fewer than 10 characters. So I think it'll pad it with spaces. The truth is, I don't know. Okay, let's find out. 1 char equals A, B, C, D, E, F, G. I think that's 7 characters. And then I'm going to print. Debug.print 1 char concatenated with a capital X, just so I can see, like, is there any space on the end of that? And I'll just stop right there. I'm going to run this by actually trying to execute this line in my immediate window. If I just try to come here and hit play, it's going to be like, what do you want to run? Because you can't run numbers. Why can't I run numbers only? It's not because it's a function. I can run functions the same way I run subprocedures. It's because it's expecting to have a value sent in for data. And I'm not giving it. If I run it this way, I'm not giving it anything. So instead of trying to run it that way, I'm just going to, up here in my immediate window, I'm going to say I want to print the result of that. And so, yeah, it is just padded that it's got 7 characters, and then it has 1, 2, 3 spaces on the end of it. And so because this is a 10-character string, if I put in fewer than 10 characters, it fills it with spaces. What happens if I try to put in more than 10 characters? H-I-J-K, 11. What if I try to put 11 characters in it? There are 2 possibilities. It'll truncate or it'll give an error. My guess, it'll truncate. I don't know, though. Yeah, it just truncates it. So it skips the K. That looks like more because I printed in the middle of something else. It just truncates at 10 characters. It takes those first 10 characters and the K comes off. But I'm only interested in a single character here, because what I want to do is I want to assign just 1 character off of whatever string gets passed in here to use that, to do something with. So I'm not printing that. I'm not stopping. Inside my loop, I'm going to say 1 char equals, and again, a little preview for something we're going to spend a lot more time on coming up. There's a function that allows me to look into a string and take some substring out of the middle of it. It's called mid. Mid says, hey, where do you want to start? I want to start at the xth character. So the first time through, x will be 1. So the first time I hit this, I'm saying, hey, start at the first character. I'm sorry, the string, the first argument is what I want to look at, data. So whatever got passed in, I'm looking at that string. I'm going to then start at the first character, and I'm going to take 1 character and return that. So mid is just going to say, let's look at this string. Let me start at the 3rd character and bring back 4 characters. So 3rd character is C. So it says there's a 3rd character, and I'm bringing back 4 characters. That's why it brings back C, D, E, F. So mid, give it a string, where to start, how many characters bring back. Now, what I'm saying is, look at the string I'm looking at is the data that got passed in. The first time through this loop, I'm going to look at the first character. Second time through the loop, I'm going to start at the 2nd character. Third time through the loop, I'm going to start at the 3rd character. You see that part? How comfortable you are with the fact that this is going to look at the first character the first time through, 2nd character the 2nd time through, 3rd character, and so forth. 5, 5, 5, 5, 5, 4. Okay, good. And then each time I'm only taking a character, just a single character. And so the first time, when I run this, the first time through the loop, it'll be 9. The next time through, it'll be 8. The next time through, it'll be 9. The next time through, it'll be the hyphen. In fact, if I were to print, debug.print, we print x, and then followed by 1 char. I'm not sure why that, oh, it's because it's O-N-E, why I didn't change the capitalization, C-H-A-R. So now when I run this, it should print 1, 9, right? Because it's printing x and then the first character, the 1 character. Then on the next line, it should print 2, 8, 3, 9, 4, hyphen. So when x is 1, 1 char is 9. When x is 2, 1 char is 8, 9, 8, 9. When x is 3, it's 9. When x is 4, it's the hyphen. So we've isolated just 1 character off of that whole string inside this loop to kind of look at. Whew. finally, we have gotten to the thing that I wanted to do today, and that was to introduce the if statement. Here's the if statement. If. Then I have required if. As soon as I say if, I must supply the then. Like there's no version of if that doesn't involve a then happening. What goes between the if and the then is some condition. It's something that will evaluate to true or false. Well, I'm trying to make this operate differently depending on if that one character is a number or not. Fortunately, there's a function built into VBA called isNumeric. IsNumeric takes an argument. I'm going to plug in one char, and it returns true if that thing is a number. I mean, not if the type of it is a number. It's expecting you to give it a string. If it looks at the string you gave it and says, you know what, I think I know what number you're talking about. You gave me a string, but I think I know the number you're talking about. If it can do that, it returns true. That's all it does. It doesn't give you the number. It just returns true. Yes, that is a number. Then what are we going to do? Let's just stop for now. I did that because I'd like to come up here and just kind of play with this function up here. So isNumeric. I'm going to print isNumeric, and then I'm going to pass it like a number. That's true. What if it's like a letter? That's false. What if it's a Roman numeral 10? Is that a number? Roman numeral 10? No, it's not a number. Like, sorry, we're talking about Arabic numbers here. By the way, where were Arabic numbers invented? India, very good. Who knew that? Nice. Why wouldn't I don't always call them Indian numbers, but I guess they kind of came to the Western world through Arabic society. So it's only Arabic numbers. How about this? How about isNumeric 1.5? What do you think? True or false? Totally true. How about 1 point? Also true. How about 0.1? Also true. How about point? What do you think? Yeah, it's not a number. You got to have a number with that decimal to actually be a number. Otherwise, it's just a period. So what I'd like to do is I would like to say if isNumeric one char. If whatever I came here, now this thing returns true or false. So let me plug in here equals true for now, but we're going to adjust that here in just a moment. So, and I'm going to go ahead and run this. Yeah, so I got to the stop because that was a number. And I'm going to go ahead and kind of run this through, and we'll just see what happens. I'll hit F5 to run again. So now it prints the 1.9 because we actually, actually, let's do this. Instead of putting stop, I'm going to move this debug.print into the position of the stop. Okay, so now what I'm saying is that I only want to execute this when this condition is true. So which number, what's the first number that I'm going to skip? Like it's going to show 1 and then 9, 2, 8. Like of the values of x that are printing, which one will not be printed when I run this? Yeah, 4 is not going to be printed because it's going to look at this one. Is that a numeric? Yes. Print off x and the 9. Is that a number? Yes. Is that a number? Yes. Go ahead and print it off. Is that a number? No. So when I get to x equals 4, one char is going to be that hyphen. This thing here is going to evaluate to what? What will the part I have highlighted evaluate to? That will be false. And so my whole condition will be false equals true, which is false. And because what's between the if and the then evaluates to false, we will skip that line. One, two, three, 5. Yeah. So we're skipping the ones that are not numbers. Delightful. Now, the thing I want to point out is that for some reason, it's comforting when you're first starting at this to have this equals true in here. But you're going to realize this doesn't even need to be here at all, because isNumeric itself evaluates to true or false. When it's true, that whole expression is true. It says true equals true. When it's false, the whole expression is false. So putting equals true on the end of something never really does anything. Because, I mean, as long as what's on the left is already a true or false value, then that will do just exactly the same thing. So I'm going to leave this without the equals true, because otherwise, if we first kind of look at the if statement and we're always seeing an equal sign in there, we think somehow that equal sign has to be there. I'm checking to see if something equals something else, and that's not the case at all. Just whatever is between the if and the then needs to evaluate to true or false. And because is numeric returns true or false, it already does. Now, instead of printing this off, here's what I want to do. I want to accumulate its values. Let me do this. Let me come up here and declare a variable called temp as a string. And so if it is numeric, then what do I want to say? I want to say that that temp is equal to, what do I want temp to be? I want temp to be what it used to be. And by the way, every string variable starts off as an empty string, so a string with no characters in it. I'm going to want it to be equal to what it used to be, an empty string, concatenated with the one character. So I'm just going to kind of work my way through here. In fact, let me put a stop right here, and I'll run my code, and then I'll step one line at a time from there. I'm going to run numbers only, and we'll step through with F8. It's coming through one char. If I hover over one char, I should be able to see it's 9, right? Is 9 numeric? Yes. And so we're going to execute the little temp. Now, right now, temp is blank. And it's going to take on a new value, which is blank concatenated with 9. So after I run this line, it's going to be 9. If I came up here and just said, hey, show me temp, it's got a 9 in it. We'll keep going. Now, the next time we're here, x has gone up to 2. One char is now going to be 8. If 8 is numeric, we're going to accumulate that. And now this is saying the new value for temp is going to be the old value, 9, concatenated with 8. So now we're going to have 9, 8 inside of temp. And if I was to print temp again, we'd have 9, 8. So we just keep stepping through this. We're going to get the 9. And now one char is that hyphen. So one char, we're looking at the hyphen. So now, what is this expression right here? This is false, so watch what happens. We hit F8, and we don't go over to that. We just skip by that because the condition was false. We only go to what's after the then if the condition is true. So if I continue running this, it should skip the accumulating every time I have a hyphen. Otherwise, it will accumulate the numbers. Instead of returning data, let's return temp. That's the whole reason we're making temp, is that's the value we want to send back. Now, I'm partway through this already, so I'm just going to hit play to continue it off, to continue it to run the rest of the way. And it should, because I told it to print whatever comes back, it should print just the numeric version of this when it comes back. Is that right? 9892879705978. Yeah, that's the whole thing. So, a long example to get to the simplest form of the if statement, which is if some condition, some expression that evaluates to true or false, and then some single line of code that I want to execute based on the condition. So now let's come back up to our data here, and let's put that in column C. So I guess we're printing off the value, that's fine. And then let's write in the numeric version of the ISBN into column C. And so we'll call numbers only, and we will pass it whatever is in column 1. So now when I run process data, I will expect it to put in the numeric version of the ISBN in column C. Let's run it and find out. Apparently I have a stop in here, so let me get rid of my stop and continue running. And I think it's only showing that in scientific notation. Oh, I wonder if it has enough precision to show 9 digits. I would think that it does. So let me come to my home, format the number, make it a comma. Yeah, so it's just defaulting to scientific notation because it's going, that's a pretty big number. You probably really want that as scientific notation. No. So I'll make this general. No, it doesn't like general. Number and no digits. Ooh. Hey, by the way, why is it doing it as a number at all? I'm sending back a string. Why is it converting it into a number? And the answer is what Excel does. You put a string into Excel that's a number, goes, you want that as a number, and it makes it into a number for you. How can I prevent it from going into a number? What would I do? If I just formatted that column as text, it wouldn't try to convert it into a number. But I kind of like that format there. So I'm going to do the format painter and then just copy that whole column. So now I've got the number. All right. So that was a lot of work to get at the simplest version of the if statement. So let's move on to the next part. The next part here, what I'd like to do is I would like to get rid of the tags, like the HTML tags that are in this. So like if it's a tag, I just want to like get rid of it. So let's make another function. I'll put it above my numbers only, so I'm kind of closer to the loop that I'm working on. Make this function, I'm going to call it strip tags. Strip tags is going to take some data as a string. It's going to return a string. I'm lost. Here we go. In fact, oh man, strip tag is going to be so close to numbers only. I probably should just copy the whole function. I'm going to copy the guts of this function, just bring it over. Because I'm going to want to look at these. I'm going to want to look at the values, the characters of data one at a time, and I'll do something different in this function based on what those characters are. So I'll leave one char defined here. I'm going to get rid of my isNumeric portion. I'm still going to have temp because based on some characteristics of this data, I'm going to be bringing values back or not. Right, so I'm not interested in looking at if it's numeric. What do I want to do now? Like someone give me an algorithm. How do I look at this and decide if I should be sending it back? Like what should this look like? I'm gonna copy this cell and kind of put it over here. What should I expect this to be? Should be like these tags should just be gone. Like that italics tag and the end italics tag. I just want to get rid of those. So I got to take what's in B now and produce what I see in D. So help me out here. Give me an algorithm. What do I just like talk to me in English? How could I know what to do? Go ahead.
Something's between the little caret signs, you can say get rid of it.
Okay, so if it is a caret sign or if it's between the caret signs, I want to get rid of it. Now let's get that down to looking at this as just one character at a time. So there's not really, well, there is. So we could kind of do it like in a kind of a broader context, but I want to say, let's look at this one character at a time. So I'm going to start off by saying, hey, I'm dealing with this one character at a time. So help me think about this. How could I, only looking at it one character at a time, what kind of algorithm could I come up with that would let me figure out if I should be bringing something in or not bringing something in? Oh, maybe there's a function like it is character. Ah, yeah, okay. So let's do this. There isn't an is character, but what there is there is something called ASC. Now, I think we've seen the ASCII table before, right? Every character has a number that underlies it. And so there's a pair of functions called ASC and CHR that allow us to kind of work back and forth between the character representation of a number and its numeric, the underlying number that we use to represent it. So capital A is number 65. So that's character number 65. I could print CHR and give it the 65, and it will print the capital A. So ASC and CHR allow me to kind of flip back and forth between the character representation and the numeric representation of something in the ASCII table. So yeah, so we can use this. Fortunately, the alphabet, capital A through capital Z, they're contiguous. There's nothing in between those. So that's good. But what I'm really interested in, when I look at a character and I see that opening angle bracket, that less than sign. Like when I see that, that's me saying, you know what? I don't want to include anything that comes after that until I see what? Until I see the closing tag. So I'm kind of looking through, you may have got some characters, regular old characters, and boom, I see this opening tag. I now want to say, I don't want any of these characters to be included until I see the closing tag that goes with it. And then anything between it should be ignored. Anything after it, we should start bringing those characters in again. So let's do this. Let's create a variable for ourselves called in tag, like in a tag. So let me dim in tag as, and I just want this to be a true or false value. Because I'm either currently, as I'm kind of looking through this data, I'm either currently between tags or I'm not between tags. And so the data type will be Boolean. We dim in tag as Boolean, and Boolean, the default for Boolean values is false. So if I don't ever make it true, it's going to be false to start off with. So let me do this. Let me come in here and say if, and then let me look at my one character. In fact, let me look at the ASCII value of my one character. If the ASCII value of that, in fact, let's do it this way. Let's actually just do a string comparison. If one char is equal to the opening tag, I'm kind of reading along. This is some it's not the opening tag. It's not the opening tag. Here's the opening tag. What do I want to do when I hit that opening tag? Oh, we are in a tag. So when that happens, I'm going to say then in tag equals true. Now, this is the simple version of the if statement. But now I want to do something else if it's not that. And so now it's not just if it's true, do something, otherwise don't do it. I'm now saying if it's true, do something. If it's false, do something else. And that requires a little bit different structure. So in that case, I don't put anything after the then. I just come and bring the thing I want to execute if it's true on the next line. And now, as soon as I've done that, I am now required to put an end if. So a statement to say, now this is a multi-line if statement. So the if starts on one line, I now have to have an end if. With the single line version of the end if, I don't need, or the if statement, I don't need an end if because it's just everything on the line after the then is what gets executed conditionally. But now I'm going to have multiple lines and it's going to be more complex. And so I've got to tell it specifically, this is the end of my if structure. So in fact, I could come do multiple lines here, debug.print x, debug.print x and one char and my in tag. So if I want to have multiple lines executing conditionally upon some expression here, if I have just one statement, it can go on the same line. If I have multiple, it's got to go on the next. They both have to go on the next line, and I now have to put the end if. But this also gives me the choice to bring in another condition, else. So if it's one char, I'm going to do this. Otherwise, I'm going to do something else. And in fact, let's look at this here. I can say else if and do another condition. In fact, we're going to say, listen, if one char is the closing tag, what do I know then? Once I find that closing tag, I'm going to say in tag equals, oh, I'm not inside the tag anymore. Else, if none of those two conditions are true, I'll do whatever's here. And in this case, I want to say I want to say else, another else if in tag, well, let's do it this way. There's a couple ways we could do this. I'm going to say else. Okay, so if I think about the structure here, what it says is great. We're starting an if statement. It checks to see if this condition is true. If it's true, we execute what's inside this, we hit this else, and we are done looking. Like there's another condition here it could look at, it doesn't matter. If that's true, it just doesn't matter. These are mutually exclusive blocks. If this one's true, we execute everything until the else if, we hit the else if, and we drop to the end if we're done. If this one's false, we drop to the next level here. It goes else, oh, this is an else if. We check to see if this one's true. If it's true, we execute what's inside it, we hit this else, and we go, we're done, and we drop out. But if this one's false, we now come look at the else. I can have as many of these else if clauses as I want. And it's just going to execute the first one that evaluates to true. Like these blocks of code are totally mutually exclusive. There is no way to get more than one of these to execute in these blocks in this if, else structure. They are totally separate. You'll find the first one that evaluates to true, it executes that block, and it's done even looking. It doesn't even check to see if any of the other ones are true. So in this case, we're going to say, listen, if it's an opening tag, just mark us as saying, yeah, we're in the tag. If it's a closing tag, mark us as saying we're not in the tag anymore. Otherwise, now we've got to decide if we're going to include the character or not. How do I know when I get here? So if I get here, it wasn't an opening tag, it wasn't a closing tag. So it's going to be like a character. It could be a capital, it could be a lowercase I. If we look at this one, that I want to skip. This I want to keep. So I got to decide. So I'm looking at this I. When I get to this I, how can I decide if that's something that I want to put into one char? So or into my temp. I'll do the part that accumulates the values in temp. Temp equals what it used to be, concatenated with one char. It's the same thing that we did for our is numeric. But now I got to have some if structure around this to decide when do I want to include it? And what does that if statement look like? Yep.
To do with what in tag is set as?
Yes. So in tag is either going to be true or false when I get here. And which of those, when in tag is true or in tag is false, which one do I want to actually include the letter in what I'm sending back? It's like a 50-50 chance. You could just guess one of them. So yeah, I think it's false. Because here we're saying, listen, if we hit the open tag, then our in tag is going to be true. If we're thinking through this, I hit that open tag, I'm in the tag. I want to skip that one. So when in tag is false is when I want to include the character that I see. So let me just show here that I can put if statements inside of if statements inside of if statements. I can say if in tag, which is itself true or false, then And I can put an indef here, even though it's only one line, I can still put it on as a block if statement. Otherwise, it doesn't do anything. But you know what I could do? I'll do this. I'm going to print off the ones that are not. So else, I'll do a debug.print. So I will debug.print all of my characters that are actually inside of the tags. And so if it's in the tag, I'm going to accumulate it in if. Otherwise, I'm going to print that one char. And then ultimately, we get to the bottom of this, and we're ready to return our temp. But our function is not numbers only. What's it called? Strip tags. So to set the name of the function, or set the return value, I set the name of the function equal to the value I want it to return. Ooh, so now when I run this, called strip tags, come up here to my immediate window to play with it, and I'll copy this text out. So if I've done this right, what it's going to print at the end is going to be like all of this text without any of the tags included. But it's also going to, like along the way, it's going to print out the characters that are inside the tag. So I should see an I, a forward slash, and then an I. Those should come here, and then it should print the full text here because this print is telling it to print the result of the function. Ooh, will it work? Can I write that much VBA at once without having a mistake? Yeah, I think I can. I think I got it. It's going to work, I believe. Nope. Oh yeah, because I've got another debug print up here. I don't want this one. This one's confusing me. So let me get rid of that print. And let's try that again. Still not quite right. If in tag, oh no, this is opposite. I want if in tag equals false. If I'm not in the tag, I want to accumulate. Yeah, I guess I can't write that much VBA and get it right. Otherwise, I want to print it. So it's doing exactly backwards here. There we go. So as we're accumulating, as we're working down through this, the very first one that we have is this open tag. And so I'm coming down here. I'm kind of looping through these. Let's see. Okay. So the very first time when x is equal to 1, one char is going to be that opening tag. And here it is. If one char is equal to open tag, is that true? That's true. The first time through, that's true. And so we set in tag, and then we drop to the and if. And that's it. There's nothing else in the loop. We go to the top. So because I don't have a print on either of these, it's never printing the actual tag markers, right? So when it gets to the I, let's look at what happens to the I the second time through. Is it the opening tag? No, that's false. One char is equal to the closing tag. That is false. Are we in the tag? Well, let's see. Is in tag equal to false? No, in tag is equal to true because the first time through, we tripped it to true right here. And so this says true equals false, which is false. And so we'll print that one character, right? So that's what prints the I. Next time character through, we're looking at this character. And so is this true? No. Is this true? Yes. So we toggle our in tag to false. We get to that else, we drop to the end if. There's no printing involved here, so it doesn't print the closing brace, a closing tag. Back up to the top. And now we're looking at the capital T. So this one's false. This one's false. So we come into here. In tag, we just set to false, and so false equals false is true. And so we start to accumulate that letter. And we just keep accumulating those onto my temp. We hit this one, This takes us into intag is true. So we'll print that, which prints this. We'll print that, which prints this. We hit this one, that takes us to intag equals false. And so the rest of these characters go onto into temp, which ultimately gets returned here. So this example shows us a couple of other things about the if structure. One is that we can have multiple lines that execute in any of these blocks. Second is that we can have both else if clauses in it as well as else clauses. And the first one that it comes across, could more than one of these be true? In this case, no, because it's asking if this is equal to something or equal to something else, but these conditions could be totally separate from each other. And so, yeah, they could all be true. If they're all true, then only the first one gets executed. If none of them are true, and we have an else, we make it to the else without executing any block above, then we execute what's in the else. The fact that this is a separate if and if block means it doesn't matter if anything about, this is like a kind of separate counting about whether something has been found or not. So we come into this one and now we've got a new if statement that evaluates kind of from scratch. It's not paying attention to did it execute any block before this or not. So the other thing is that we can nest if statements inside of if statements inside of if statements. And in fact, the VBA interpreter, like there may be some limit. I've never found the limit of nesting ifs. Like you can nest really deeply. There may not be a limit, I don't know. But I'm going to tell you what the human limit is for nested ifs. It's 2 levels. You nest 3 levels, and it is kind of beyond the workings of a normal brain to be able to look at that and just get it. So it's just like a red flag to yourself. If you ever say, I'm nesting 3 levels here, you need to say, I am now kind of walking out onto the edge. I need to be really, really careful about what I'm doing. It's just difficult for the human processor to deal with it. But the VBA processor is like great with as many levels as you want. Okay. Ooh. But now I think I'm ready to show the tagless version of this in column D. So this is called strip tags. I'm just going to come and put the result of that into column D. So column D is going to be strip tags, and I'm going to send it what's in column 2. And that should now give us something that looks much like this going down column D. All right, I'm going to get rid of my debug.print in here. I don't really want to be printing that out. That was just kind of for debugging. All right. Next thing I want to tackle is something that I think is a little bit quirky about this data and somewhat unexpected. In fact, let's just find out if I remember this correctly. I'm going to look at this data right here, and I'm going to use a built-in function to Excel called trim. Who can tell me what trim does inside of a cell? What does trim do? Anyone know? It's exactly what it does. It says you've got a space before or after whatever's in that cell. Trim will just take off all of those. But not only will it do that, if you've got multiple consecutive spaces inside of a string, it'll collapse those down into just a single space. Let me just look at an example here. Let me put in something here that's like equals, or just put it as a string, to Nephi, seer of a bunch of spaces, olden time. Oh, yeah, or he's an herb seller now. There we go. It's to Nephi, seller of olden time. All right. If I was to use trim on this, and if I had like some spaces at the beginning, and it's hard to see the spaces on the end coming off, then we can see the result of this function. It's got rid of the ones at the beginning and all those consecutive spaces in the middle. That's what trim does. But does anything look hinky about what's coming back from this one? So I'm trimming what's in D1. What looks wrong about it? Look at this one. Aren't there two spaces right there? Why, oh, why isn't it trimming those? Why isn't it? In fact, are they still there? I think they're still there. They look like they're still there. It's hard to see because if I do it to edit that, I'm just going to see the thing. So let me just kind of paste this out here in my immediate window. Yeah. There's still two characters in there. Yikes. Who knows? What evil has beset this formula? Turns out there's more than one kind of space. What? That's evil, isn't it? And who do we have to thank for this? The internet. I always knew the internet was evil. What's the other kind of space you can make if you're like you HTML conversant folks? What's the other kind of space you can make? It takes a special code in HTML to do it. What is it? Yeah, it's called a non-breaking space. Like if I'm like right along in HTML kind of automatically does what the trim function does. If you've got like multiple spaces, like when you render that, it collapses them down to a single space. If you've got like multiple vertical lines, like just blank lines, it collapses those down to a single space. So if you're saying, hey, you know what? I want some spaces in here just to not collapse, instead of using the space bar to do it, like in HTML, it's like the code is ampersand NBSP semicolon. Like you put that into your HTML and that makes a non-breaking space. You see it, NBSP, non-breaking space. And then that tells the browser, don't collapse this one. Like if there's 3 or 4 of these together, leave 3 or 4 of them together. So wherever this data came from, like the folks who made the folks who made the web page that put that in there, they said, I want 2 non-breaking spaces right here. And when you copy a non-breaking space like off a web page and paste it into Excel, that non-breaking space is still a non-breaking space. Even though I don't really know. Oh yeah, I guess I do know a way that you could put it in, but it's kind of hard. It's difficult to type. It's non-typable. You cannot type the non-breaking space. Like you could copy and paste it. In fact, let's look at this. Let me do this. Let me just say, you know what? I want to print the ASCII value of a normal space. It's 32. Like a normal space is character number 32. Now let me just copy this space right there. I'm going to copy that. I'm going to paste that one in here. It's also 32. So by the time it gets here, it's still 32. So that's no good. So we've pasted that in here and it's converted from a non-breaking space into a 32 space. So I'm going to have to go look over here at my active cell. So let's do this. Question mark active. Okay, active cell dot value. Now what I want to do is I want the mid of my active cell dot value starting at something. Where do we want to start? I don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 34, 32, 33, 34. Let's just look at 34. I've active cell 34 taking 1 character. I think that's going to print, if I counted right, that's going to print the closing tag. Oh, and then I didn't tell it how many characters to bring, so it brought the rest of them. So I'm going to bring just 1 character. Okay, so that's this character. I'm after that next one right there. But let's do the ASCII value of that, and we'll find out what the ASCII value of closing tag is. It's number 62. Now let's move over 1 cell, 34.1. I must have meant to hit a comma, and I hit a point instead. So now let's look at 35. It's still 32. think that should be like 160 or something.
You have a space with an non-breakable space.
Oh, good. It actually might be a regular space. So let's look at the next one over. 35, 36. Ah, who said that? You, sir, get a gold star for the day. Email your mother and tell her you got a gold star for the day. Yeah, so that actually was, that was just a space. And so maybe this one is actually maintaining. So let me just try this one real quick. ASCII value of that space. Yeah, so it was a 32 space followed by a non-breaking space. Excellent. So now I would like to have something that can do what this meager trim is unable to do. And that is, I want to get rid of everything that is not like in the normal range of the ASCII table. Let's take a look at what I mean by that. Let me just look at the ASCII table. Oh, images. Let me a good image. There's a decent one. Opening a new tab. Not the best one I've ever seen, but it'll do. So here's number 32. That's a space. Here's 33. It's an exclamation point. 34 is a quote. Here's capital A. It's 65. Here's lowercase a. It's 97. Everything before 32 is like some kind of a control character. Like number 10 is a line feed. Like literally, these originate from like sending keystrokes to a printer. I'm sending characters to a printer to print something. When I send character number 10, it tells it advance the paper. When I send character number 13, number 10, yeah, advance the paper. But number 13, it's usually called carriage return. That's why the abbreviation is CR. That tells it to move the print head back to the beginning. If I send it a 7, it tells it to ring the bell. Ding. Like these are all control characters you'd expect to have on an old school printer. But we use the same numbering space for like just characters in a text file. And so that's why we have all these numbers over here. So here's what I'd like to do. If it's below 30, if it's below 32, I want to ignore it. If it's above 127, I want to ignore it. That'll get rid of that'll get rid of the 60 and other strange things. It'll get rid of the space, the 160. So what if I come here and say, you know, what is character number 61? It's like some funky equal sign, but it's not the equal sign not character 61. What's 161? 61 is the equal sign. It's like an upside down exclamation point. What's 162? It's a cent sign. What's 163? Pounds. Look, and by the way, all those above 127, those are all suspect because that's the way that this computer is showing that one, but another computer might show it differently. Have you ever seen a web page that, you know, it shows the web page and it's got like question marks where some characters are? Raise your hand if you've seen that. You've gone to a web page and it has a little question mark. That's because it's saying, oh, there's a character that I don't recognize like the character number for it. It's something above 127 and maybe even higher than 256. And so I'm going to say, listen, whatever that character is, if it's not in the range that I'm expecting, 32 to 127 is the base characters, just ignore it. That'll be the last example that we hopefully can do in the next 10 minutes. I'm going to go ahead and start off this example by copying my strip tags. It's going to be similar to strip tags. I've copied that now, and I'm going to call this one, I'm going to call it super trim. I'm going to send it in data. It's going to give me back data. I'm still going to iterate through all of these. I guess I'm going to take my for next loop and kind of start from there again. And instead of strip tags equals temp, super trim equals temp. So that'll return whatever we accumulate in here. Now in this case, I want to just look at the ASCII value of the character. So before we were going to accumulate the character if it was numeric. Now what I'd like to do is accumulate the character if it is in the range that I'm interested in. So if the ASCII value is in the range that I'm interested in, so let's do this. We're gonna do something that's similar to the if, else if clause, but it's got one little difference, and it's called the select case. I think it's another way to do conditional branching. I'm gonna say select at the beginning, I'll say end select at the end. Now, in this case, I want to look at, whoops, I deleted too much because I still want my one char to be defined here. So this select is, I'm going to do several different things based on what is like the ASCII value of that character. So I'm going to say, listen, I'm going to start off by saying, I'm going to be looking at the ASCII value of the one character. So I'll say select case ASC of the one char. And then I'm going to have like several case statements inside this. I'm going to case 160. 160 is a special value for me. If it is a non-breaking space, I want to convert it into a space. Like it's a special one. So, so this is like breaking that condition down between these two. I'm saying if this expression here is equal to this, I want to do something in particular. And what is it that I want to do? I want to say one char, I'm sorry, I want to say temp equals what it used to be concatenated with a space. Don't plug a non-breaking space in here, plug a regular space in here. If it's the same thing, if that one is true, like if this comparison is true, then it's like, great, we are done looking. But if that one's not true, we'll look for the next case statement. Case is greater than 127. Then we'll do something. What do we want to do here? I think if it's any other character above 127, what should we do? Shall we replace it? Let's replace it with an underscore. I don't know that we're going to have many in there. So in that case, we're going to say temp gets an underscore on here. If it's less than, case is less than 32, let's concatenate on a hyphen. Otherwise, let's just accumulate whatever the number is. So case else says, hey, if I made it to case else and didn't do any other cases, temp is just going to accumulate that character. Now I think my data has only that one character. But let's go ahead and try to plug a 163. This is our little pound sign here. Let's kind of plug that in here. So I'm going to try to run super trim. And I'm going to super trim whatever is in like this. But I'm going to concatenate onto the end of that. Erg, hit undo. There's no undo in the immediate window. You make a mistake in the immediate window, you have to live with it. I'm going to put on character number 163 in that super trim. So that should give us an underscore here. And then I'm also going to give it something small, like a character number 10. That should give us a hyphen. So now, if we look here, I think those are two normal spaces. We could check that by putting trim, which is a VBA statement similar to, oh no, we can't because it wouldn't do the inside. We'll just have to peek at that. We'll have to peek at both of these. There's the first one. We expect that to be 32. And here's the second one, which should now be 32 as well. But we can see that the high character then got replaced with an underscore. The low character got replaced with a hyphen. So the idea behind select case, it's just the same as if, else if, else if, else if, else if, except this one jumps up and down and says, I am looking at all of my comparisons come back to a single expression. They're mutually exclusive, just like the if, else if. And this is like another structure that we use for doing conditional branching. All right, folks, that's it for today. Have a good day, and I will see you on Wednesday. Class dismissed. You're too kind. You're too kind. Thank you.